syntactic transfer. You look at certain phrases, and if I have a very large corpus, these are all trained on parallel corpora. So you have, here's a paragraph of, the European Parliament, paragraph description in German, here's one in English, and one in French, and one in Italian, and so on. And you might say, well, that particular phrase, not just the word, but that phrase often co-occurs with that other phrase in the other language. And then, basically you can parse and try to translate whole phrases, and then sometimes you see the whole sentence, and maybe you can try to translate the whole sentence right away. That is the next level. And then you can use the semantic level and say, well, sometimes I describe this in terms of logic. X made Y happy. And now I have this interlingua, the sort of language between the languages that abstracts away from all the complexities and subtleties of each language and has one general description, which is also very, very hard if you know like different cultures and so on. And you might say, okay, I will translate everything into this logical or very discrete semantic representation, and then I will just generate a surface form, a specific way to describe that. So what do people think is the interlingua for deep learning? Exactly, it's vectors. And so this is a very recent result from just last year. There are actually a couple of groups that are starting now to use deep learning for machine translation. But basically, the crazy result here is we could literally take word vectors, we squeeze them through a very deep, very powerful deep learning architecture, and we take the entire sentence and we just describe it in terms of one vector. And we have another neural network that just says, now translate that vector from the previous language into the other language. And it kind of works. This system is not yet as good as the system that Google has built over the last 10 years, and with many, many millions of dollars and lots of brain power. But in just 1 year, one group of deep learning experts could build a system that's actually very competitive. And if you can do that so quickly, it's only a matter of time, I think, but again, I'm optimistic and slightly biased, that it will outperform human systems. Because unlike for sentiment, it is basically impossible to describe all the features for machine translation by hand. Right? You can have no set of people could do that. It changes over time. It's incredibly complex. We had a question there?
So could it actually be transitional so that if I translate from English to German, like by just having training examples, English, French, and French, German?
You can do that. In fact, some people, you could do that with any system, and it just gets worse and worse. And at some point, it's so ridiculous. I think there's a video on YouTube where people translate a song lyrics like 5 times through a translation system, and it just comes out pretty much garbage. But it's possible. All right, this was today's first lecture, very high level, very bird's eye view. In the next lecture, we'll actually look at the first and most important representation that all these different models start from, which is word vectors. And we'll see that these models capture lots of interesting facts about them. Thank you.